Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology lecture videos. The topic of today's video is the catalytic properties of nanomaterials under nanotechnology. Before I start today's topic, I would like you to please subscribe to my channel if you have not done it so far, and to also share this video among all your friends and colleagues, especially to those who want to learn nanotechnology in detail. So let's begin with today's topic. We will start with the definitions of catalyst and catalysis along with the examples and important characteristics of a catalyst. So let's begin with the definition of catalyst with examples. Catalyst is a substance that changes the rate of a chemical reaction without itself undergoing any permanent chemical change. They are not consumed in the reaction and remains unchanged after the reaction is over. The examples are iron, which acts as a catalyst in the synthesis of ammonia by Haber's process, nitrogen peroxide and platinum that acts as a catalyst in the manufacture of sulfuric acid, zeolites, which acts as a catalyst in the cracking process of petroleum. And there are many more examples of catalysts. Define catalysis. The process of increasing the rate of a chemical reaction by adding a substance which is known as catalyst, which itself remains unchanged at the end of the reaction, is called catalysis. State some important characteristics of a catalyst. The important characteristics of a catalyst are: it does not initiate a chemical reaction. That is, it does not start a chemical reaction. It does not get consumed in the chemical reaction. It reacts with the reactants to form intermediates and facilitates the final reaction product. Its physical state may change after the reaction and it may get poisoned too. What is a nanocatalyst? Nanocatalysts are the catalysts made up of nanoparticles or some other nanostructure such as nanofoam. They act like a regular catalyst that changes the rate of a chemical reaction without itself getting altered or changed, but with many folds better efficiency. What are the different types of nanocatalysts? Various types of nanocatalysts have been reported, including supported nanocatalysts. They are Schiff-based nanocatalysts, graphene-based nanocatalysts, thin film nanocatalysts, mixed metal oxide nanocatalysts, magnetic nanocatalysts, and core shell nanocatalysts. What are the types of nanocatalysis? It is of two types, same as the normal catalysis: homogeneous and heterogeneous nanocatalysis. What is the difference between homogeneous and heterogeneous nanocatalysis? In a homogeneous nanocatalysis reaction, the nano-sized catalysts are in the same phase as the reactants and remain in maximum contact with them. Whereas in the heterogeneous catalysis, the nanocatalysts and the reactants are in different phases. Here phase means it could be in the solid, liquid or gaseous phase. So in the homogeneous nanocatalysis, the reactants and the nanocatalysts are in the same phase. That means if a liquid is used as the reactant, the catalyst will also be in the liquid phase. But in the heterogeneous catalysis, the reactants and the nanocatalysts will be in different phases. Explain homogeneous nanocatalysts. Homogeneous catalysts are used in the same phase as the reactants. For nanoparticles, this typically means a solution or suspension of nanoparticles in a solvent. So they are in the same phase. Reactants is a liquid, then nanocatalyst will be also in the liquid state. What are heterogeneous nanocatalysts? This involves a catalyst which is in a different phase to the reactants. The catalyst is usually solid or immobilized on a solid inert matrix. And the examples are zinc oxide, niobium pentoxide and titanium dioxide. What are the major drawbacks of homogeneous nanocatalysis? The main concern with homogeneous nanocatalysts is its recovery. Nanoparticles are extremely difficult to remove from a solution, so extra steps are needed. This non-recovery of nanoparticles poses an environmental risk as well as threatening to the profitability of the process because extra steps are required for its removal. What are the benefits of heterogeneous catalysis? It involves catalyst which is in a different phase to the reactants. These are usually solid or immobilized on an inert matrix. This addresses the issue of waste and recoverability as the solid catalyst can simply be filtered out, thus making the catalysts eco-friendly. Does bulk gold also used as a catalyst? Why nanoporous gold is a good nanocatalyst? Gold in its bulk form is inert, but nanoporous or nanoparticulate gold is a good catalyst. It acts as a good catalyst in oxidation of carbon monoxide in catalytic converters. Nanoporous or particulate gold is preferable as nanocatalyst due to its stability and recoverability. Explain the role of graphene and CNT, that is carbon nanotubes, as nanocatalysts. Both the materials, graphene as well as CNT, have great potential and shows interesting and unique chemical and electrical properties. The spatial restrictions caused by their unusual dimensionality causes changes in their electronic structure. These properties of the materials makes them promising electrocatalysts. What are the advantages of titanium dioxide nanotubes as nanocatalysts? Titanium dioxide nanotubes are most favorable because of their high catalytic efficiency, high chemical stability, cost effectiveness and least toxicity. Another advantage of this nanotube is that it can be recycled and reapplied in many photo-degradation cycles. New researches have shown that titanium dioxide nanotubes maintains 80% activity even after 10 cycles of reactions. How are nanocatalysts different from their bulk counterparts? Nanocatalysts have much higher surface to volume ratio as compared to their bulk counterparts. And this I have already discussed in one of my previous videos, the surface to volume ratio. Please refer to that video if you want to learn the properties due to surface to volume ratio of nanomaterials. So when the size of the catalyst decreases to nanoscale, then prominent changes, especially in the electronic states and coordination environment of the surface atoms of the catalyst takes place. These changes increases the reactive sites in the nanoparticles to a great extent, thereby making it a better catalytic material than its bulk counterpart. What is the role of nanocatalysts in fuel production? Nanocatalysts plays a major role in fuel production such as bioethanol and biodiesel. They increase the reaction rate by contributing a greater number of active sites due to their increased surface area to volume ratio. So, surface area to volume ratio is an important property and it should not be forgotten if you are learning the nanomaterials and the properties of nanomaterials. What are the advantages of nanocatalysts? Give examples. Compared to regular catalysts, nanocatalysts possess unique advantages such as an enhanced mixing with the reactants, easy separation from the reaction mixture due to their insolubility in various solvents. They also enables rapid chemical conversion with a higher yield and simple catalyst separation. Aluminium, iron, titanium dioxide and silica are some examples that can be utilized as nanocatalysts. What are the applications of nanocatalysts? Some important applications of nanocatalysts are in photocatalytic decolorization, in degradation of large amounts of textile dyes such as malachite green, methylene blue and other azo dyes, production of biofuel, hydrogen energy carrier, the nanocatalyst in solid rocket propellants, in water purification, in waste water treatment and in agriculture, in controlling the pests and weeds, in food processing, packaging and in preservation of the food. What are the disadvantages of nanocatalysts? Nanocatalyst suffers many serious problems such as toxicity and product recovery of the catalyst after reaction and residue generation. All these problems limits the applications and scope of the nanocatalyst to a higher level. How the disadvantages of nanocatalysts be addressed? Preparation and manufacture of green nanocatalysts can be the solution to the problem. What are green nanocatalysts? Green nanocatalysts refers to synthesizing the nanocatalysts using plant extracts and this is called green processing and the nanoparticles formed are green nanoparticles. They are dispersed in green solvents. What is green nanocatalysis? Green nanocatalysis refers to doing the catalytic reaction in green solvents preferably by the use of green nanocatalysts for reactions. What is the preferable size of green nanocatalysts? The typical size of green nanocatalyst is 2 to 3 nanometers since this is the optimal size range for many catalytic reactions. What are the advantages of green nanocatalysts? Give examples. Increased energy efficiency, reduced waste and greenhouse gas emission and decreased consumption of non-renewable raw materials are the main advantages of green catalysts. Phytocatalysts, that is catalysts obtained from plant extracts are the examples of green nanocatalysts. Silver and gold nanoparticles obtained from seed and leaves extracts are some of the phytocatalysts used in the modern technology. Why chemical properties at nanoscale different from its bulk counterpart? The percentage of surface atoms in nanoparticles is very large compared to the bulk materials. Therefore, reactivities of nanomaterials is very large compared to the bulk counterparts. What are the chemical applications of nanomaterials? Nanomaterials possess special properties due to their small size. They have a high surface area and therefore they act as very good nanocatalysts. The main applications in the chemical engineering field are as catalysts, sensors, coatings, adsorption and drug delivery. On what basis the nanoparticles be characterized? They are characterized on the basis of its surface charge, functional groups and catalytic activity. And the catalytic activity is mainly dependent upon the surface to volume ratio. What is the chemical classification of nanomaterials? Nanomaterials are chemically classified on the basis of their composition into three types: organic, carbon-based and inorganic nanoparticles. Define chemical properties with examples. State the role of catalysts in chemical activity. The irreversible change of one type of matter into another type is called a chemical property. Examples are flammability, toxicity, pH, reactivity, chemical stability, radioactive decay and combustion. Catalysts help to bring about a change in the state without itself taking part in the chemical reaction. How is physical property of a substance different from its chemical property? Physical property is defined as the characteristic of a substance that can be measured without changing the identity of the substance. It includes color, density, hardness, melting and boiling points, malleability, solubility and electrical conductivity. Whereas the chemical property is the ability of a substance to undergo a specific chemical change where the original form changes into another form. It includes rusting of iron, burning of fuel, formation of salts, oxidation, combustion and evolution of hydrogen. Does nanoparticles have different chemical properties than its bulk counterpart, and why? Nanoparticles have unique and different physical and chemical properties from its bulk counterpart, and this is due to its nano size and increased surface to volume ratio properties. Why the nanomaterials act as great catalysts and are highly reactive? They act as great catalysts and are highly reactive because of the reasons stated here. The large surface area is a major reason for the nanomaterials to act as good catalysts. At the nanoscale, around half of all the atoms in the nanoparticles are surface atoms. Therefore, properties such as electrical transport is no longer determined as in the bulk phenomenon. Atoms in nanomaterials have high average energy than atoms in the bulk structures due to the larger proportion of surface atoms. Therefore, catalytic materials have a greater chemical activity, and the atoms of exposed surface when the catalyst is reduced to the nanoscale. Defects and impurities are attracted to the surfaces and interfaces. Thus, the interactions between particles with those at small dimensions depend on the structure and nature of the chemical bonding at the surface. And molecular monolayers are used to change or control the surface properties and also to mediate the interaction between nanoparticles. So, these are the reasons why the nanomaterials act as great catalysts and are highly reactive. State the various types of nanoparticles based on their chemical properties with examples. The various types of nanoparticles are stated as carbon-based nanoparticles, which includes fullerenes and carbon nanotubes. CNTs are two major carbon-based nanoparticles. Metal nanoparticles, they are made up of metal precursors. Their localized surface plasmon resonance LSPR characteristics gives them unique optoelectrical properties. Ceramics nanoparticles, these are inorganic non-metallic solids. They could be in amorphous, dense, polycrystalline, porous or hollow forms. Important applications are in imaging, catalysis, photocatalysis and photodegradation of dyes. Semiconductor nanoparticles. They have properties between metals and non-metals. Wide band gaps are important in these materials. Hence, used in photocatalysis, photo-optics and electronic devices. And the polymeric nanoparticles. They are mostly nanospheres or nanocapsular. Nanospheres are matrix particles whose overall mass is solid and the nanocapsular molecules are adsorbed at the outer boundary where the solid mass is encapsulated within the particle. Are nanomaterials toxic? Nanoparticles are more toxic to human health in comparison to the large sized particles of the same chemical substance. The toxicities are inversely proportional to the size of the nanoparticles. What is toxicity in nanotechnology? The mechanical effects due to the physico-chemical properties of nanoparticles cause toxicity. The basic mechanism of toxic effect formation in nanoparticles is formation of reactive oxygen species, abbreviated as ROS, either directly or indirectly. ROS, that is reactive oxygen species formation, is toxic in vitro by multiple mechanisms in the cell. What is the major disadvantage of nanomaterials? Major disadvantages associated with nanomaterials is considered to be inhalation exposure. Nanomaterials such as CNT, carbon nanotubes and nanofibers may cause pulmonary fibrosis, which is irreversible and fatal. What are the toxic effects of nanomaterials on environment? Nanomaterials contaminates not only the soil but also the groundwater. From surface soil, it percolates down to contaminate the groundwater. The suspended nanoparticles in air makes the air toxic and unbreathable. Which nanoparticles are most toxic and where does it find applications? Copper oxide nanoparticles are most toxic. They are used as antimicrobial agents in plants. What are the future challenges of using nanocatalysts? The future challenges of using nanocatalysts lies in reducing their toxicity by improvising its properties, manufacturing and processing, better handling, recycling and disposing of techniques. Preparation of green nanocatalysts could be a great leap in this direction. Give some examples of toxic nanocatalysts and the damage caused by them. Commonly used nanoparticles of silver, zinc oxide and titanium dioxide are highly toxic. They induce oxidative stress, mitochondrial damage and cytotoxicity, carcinogenesis, genotoxicity, even in mammals and humans. What are the reasons of toxicity in nanoparticles? The main reasons for the toxicity of the nanoparticles is its increased surface charge. The higher the charge on the nanoparticle, the greater is its electrostatic interactions with the cell. Hence, the greater will be endocytic uptake, leading to DNA damage. Therefore, its dosage should be monitored, knowing the potential risks of the nanoparticle exposure. Here we come to the end of this video. Keep watching my videos and also share these videos among all your friends and colleagues.